Take a look at an ordinary, empty plastic container. Most people see something headed for the recycling bin. But look closer, and you'll find a highly engineered, rigid polymer structure. We just need to access its underlying material properties. This exact piece of everyday waste can be structurally re-engineered into a high-utility custom workbench organizer. This transformation bypasses blunt mechanical force, relying instead on precise thermal manipulation to reshape the polymer. Before starting, you need a controlled setup. Heavy ventilation, thermal heat-resistant gloves, and an industrial heat source are strict prerequisites for this operation. Mastering this thermal process changes your relationship with common materials. You stop viewing them as simple single-use objects and start treating them as raw stock for custom fabrication. Step 1 is establishing a sterile workspace. The plastic surface must be completely dry before applying any thermal energy. Microscopic moisture left on the plastic acts as a volatile variable. When heated, that water boils instantly and irreparably warps the surrounding polymer matrix. Target the thermal transition zone. This precise medium heat setting safely alters the plastic state without triggering combustion. Localized heat will melt right through. To keep the temperature stable within that safe zone, your heat source must remain in constant sweeping motion. In materials manipulation, patience and continuous kinetic motion are the actual tools. They prevent catastrophic failure and set the stage for the structural alteration. Now we begin the structural alteration. We start with the front heating technique, focusing the heat strictly along the primary intended seam. Spatial geometry is critical here. Maintain exactly 2 to 3 inches of physical distance between the heat emitter and the polymer surface. Heating one side only penetrates the upper half of the material's core. Bending a half-heated section causes the cold underside to snap. Use reverse heating. By applying an identical thermal load to the opposite side, energy equalizes throughout the core, preventing stress fractures. Look at this comparison to spot malleability. Cold, rigid material has a dull, matte finish. Properly heated plastic develops a highly reflective, glassy sheen. This glassy phase is transient. Structural manipulation must begin immediately before the thermal energy dissipates. Achieving this dual heating equilibrium is what allows rigid, mass-produced consumer plastics to bend as if they were fluid. With the material softened, shift from thermal application to mechanical leverage. Move the container to the hard, straight edge of the workspace. Wearing heavy heat-resistant gloves, force the softened polymer over the hard edge to form a clean, sharp crease. Maintain downward kinetic force at the exact intended angle. Ensure the vector does not drift as the material sets. If you release pressure too early, you encounter structural thermal memory, the polymer's tendency to slowly warp back towards its original factory shape. Hold a strict, unmoving position for 45 seconds. Let the ambient air dissipate the residual heat. While you hold it there, the chaotic, heated polymer chains lock back into a rigid, crystallized lattice in their new configuration. The true act of fabrication happens during the cooling phase. This is where the material's new purpose is permanently encoded into its structure. Verify the structural integrity of the newly cooled plastic. When tapped, it should yield a hard, rigid acoustic sound, confirming the bond has held. These same principles can be applied to create a wide variety of custom tools and household organizers from standard containers. Discarded polymers retain their structural durability long after their original contents are gone. This durability allows for significant reuse through reshaping. Analyze your own workspace for inefficiencies. You can likely find a geometric solution by applying this thermal protocol to the materials already in your recycling bin. Just remember, rigorous environmental ventilation and thermal protection are the necessary boundaries of home fabrication. Instead of searching for a store-bought solution, you now have the method to modify existing plastic into a specific tool designed for your own workspace.